This is the video for Lesson 7.1, Apply Exponent Properties Involving Products. We're going to have several properties that we're going to learn about this lesson, the first of which is the product of powers property. In words, this says to multiply powers having the same base, we're going to add the exponents. So for example, if it was a to the mth power times a to the nth, we would simply keep that base and add the exponents m plus n together. To use numbers, if it's 5 to the 6th times 5 to the 3rd, notice common base of 5, we're going to add our two exponents together and rewrite it as 5 to the 9th. So let's try example 1. We're going to use the product of powers property. For letter A, 7 to the 3rd times 7 to the 5th, we have the same base of 7. We're going to keep that base of 7, and we're going to add the 3 and the 5 together, and it's 7 to the 8th power. Notice we don't multiply our two bases together. Okay, that would be too big. We need to keep that same base in our answer. In letter B, okay, our helpful hint on the side over here says to remember that a base with no exponent really has an exponent with an invisible 1. So this first 9 really has an exponent of 1. We have a common base of 9, so we're going to have 9 in our answer. We're going to add 1 plus 8 plus 2 and get 9 to the 11th power. In letter C, once again, we have an invisible exponent. Our base is negative 5. We're going to add our exponents together, and it's negative 5 to the 7th power. A good rule of thumb when you're doing these questions, if the problem has a number in parentheses, it's best to write your answer also involving those parentheses, because we know when we throw negatives on the inside versus the outside with exponents, sometimes we get different answers. So we want to make sure that if there are parentheses, we keep the parentheses. Okay, another helpful hint, when simplifying powers with numerical bases only, we're going to write our answers using exponents. So just like we did in A, B, and C, there are no variables, just numbers. We're just rewriting it with the exponent. I'm not going to sit there and make you do 7 to the 8th power. That's just evil. So just leave it as 7 to the 8th. In part D, we have some variables, okay, but the rule is the same. We have a base of x. We're going to add our exponents together, so it's x to the 7th. Now E and F are a little bit different, because notice we have some coefficients thrown out front here. When we have coefficients, okay, we are going to keep multiplying those just like we normally would. This new rule only applies to the exponents. Okay, so we're not going to be adding our coefficients together, we would be multiplying them together. So here, we're going to do 3 times, I guess this one would technically be 1, so it'll just be 3. And then with our common base of x, we add our exponents, and our answer is 3x to the 10th. For letter F, we multiply 4 times 3 together to get 12, and add our exponents on the a's, and we get 12a to the 7th. Okay, some guided practice. Okay, please pause the video, try them. They should be pretty quick, and then replay when you're ready. Number 1, our base is 3. Add the exponents, we get 3 to the 9th. Remember, just numbers, we leave it that way. For number 2, there's an invisible 1 there, so we would get 5 to the 10th. For number 3, once again, an invisible 1. Since it's in parentheses, let's write those parentheses, and we get negative 7 to the 3rd power. On this one here, we're going to multiply our coefficients together. 2 times 6 is 12, and with our x's, we have 2, 6, and 1. Adding those together gives you 12x to the 9th. And that's our first property. Now we're going to move on to power of a power properties. Okay, these are all kind of tongue twisters. So for this one, to find a power of a power, we're going to multiply our exponents together. So if it's in algebra, a to the nth power, but that raised to the nth power, be a times m times n. Sorry, a to the power of m times n. For numbers here, we have 3 to the 4th, but then that quantity is raised to the 2nd power. We're going to multiply our two powers together, and in the end it's 3 to the 8th. So in letter A, power over power. We're going to multiply our powers together, and it's going to be 2 to the 15th. For b, notice parentheses, keep the parentheses. So it's negative 6. Power over power, we multiply our exponents. So it's negative 6 to the 10th power. For letter C, multiply your exponents. It's going to be n to the 18th. And for D, notice in parentheses, let's keep it that way, but 5 times 4 means it's m plus 1 raised to the power of 20. Okay, flip it over. Try your guided practice question, so pause the video and then press play when you're ready. For number 5, multiply our exponents for power over power, and we get 4 to the 14th. For number 6, be negative 2, 4 times 5 is 20. For number 7, be n to the 36th power. And for number 8, it'd be 3n plus 2 raised to the power of 12. And our last property of the lesson, power of a product. Okay, notice they all sound very similar, so it's going to be a little tricky to keep them separated. Okay, but power of a product property says to find a power of a product, you're going to find the power of each factor and multiply them together. So if it's AB, that quantity raised to the power of m, we could split it up and say a to the mth times b to the mth. Okay, notice there's no plus or minus in here like there was in some of the previous examples we did. Okay, the inside has to be a product. In numbers, if it's 23 times 17 to the 5th power, we can break it up and say 23 to the 5th times 17 to the 5th. Once again, not going to make you calculate that. So in example 3, we have a product, we have a power. We're going to do power of a product property. So 24 to the 8th times 13 to the 8th. And that's it. For b, okay, we're going to apply this squared to every single thing that's there. I'm going to split it up. I'm going to assume that most of you might be able to jump right to the answer, but just to show you where our answer is coming from, we're going to split it up like 9 squared times x squared times y squared. And in this case, when we have both numbers and variables multiplied together, okay, we have monomials here, okay, we are going to calculate what this is going to equal. Okay, I promise they should not be that bad. Okay, I will not make you do crazy ones like in letter A. So, however, when you have numbers and variables, multiply it further. So 9 squared is 81, and then it's just x squared, y squared. Once again, if you can jump right from here to the answer, perfectly okay with that. In C, we have to be careful here because we have a negative. Okay, so that squared is going to be applied to both of them. So I'm going to say negative 4 squared times z squared. And let's take this a step further. Negative 4 times negative 4 is a positive 16 with a z squared attached to it. In D, notice that negative's out front, so it's going to be negative, oops, disappeared, negative 4 squared times z squared. Order of operations, okay, means we ignore that negative and we do our exponent first. So it's 16 z squared with the negative out front. Okay, so obviously C and D are very similar. Please make sure you're paying attention to where the negative is. Okay. Another guided practice, so please pause the video once again and play when you're ready. Okay, number 9, all we're going to do is 42 to the 4th times 12 to the 4th, and that's it. For number 10, okay, when we have that negative that we need to take the exponent of, I'm going to put in the parentheses first, so negative 3 cubed times n cubed, and this value right here is a negative 27 n cubed. Number 11 would be 9 cubed times m cubed times n cubed. 9 squared is 81, and 81 times another 9 would be 729, m cubed, n cubed. And finally, number 12, it's going to be negative 5 squared times x squared. So final answer, negative 25x squared. Okay, example 4. Use all three properties. Okay. Now, with these, I broke it down for you step by step. However, you're not always going to do them in the same order. Okay. With all these, it's possible to kind of mix up the properties as you go. Okay. But you want to make sure you take care of each one piece by piece. So first, I see a product and a power. So I can apply the power of a product property, which means this squared is split up between both of these. So it's going to be 2 squared times x cubed squared. And I'm just going to bring down that x to the 4th. Now I can simplify this, that's 4. But now right here, that's going to involve my power of a power property. Okay, power of power says we multiply our exponents together. So that part's going to give me x to the 6th. And finally, product of powers, the same base. Okay, I'm going to keep that base and add my exponents together. And my final answer is 4x to the 10th. Okay, try the guided practice questions on the next page and hit play when you're ready. For number 13, we have to do the power of the product first. So I'm going to say 5 times 5 cubed times x squared cubed. Okay, these here, okay, that's really 5 to the 4th power, which I am going to have to take a step further in a second. And this x squared to the 3rd, multiply your exponents, you get x to the 6th. Okay, and I did say before that when we have numbers with variables, we're going to multiply the numbers out. 5 to the 4th is really 5 squared times 5 squared, which means it's 25 times 25, which gives us 625 x to the 6th power. For number 14, power of a product, so 3 cubed times d squared cubed times 2d squared. Once again, some of you might not even write this out. Okay, you're kind of going to jump right to it, and I'm okay with that. But 3 cubed is 27. That would be d to the 6th times 2d squared. We have some coefficients we're going to multiply. Ooh, that's hard to see. So we have some coefficients, and we're going to add our exponents together. So that should give us 54 d to the 8th. That was a 6. So 54 d to the 8th. And number 15, it's going to be negative 4 cubed. Notice I put it in parentheses because the negatives can get tricky. S squared cubed. This one's going to be 2 to the 6th times s cubed to the 6th. Negative 4 to the 3rd power, that's negative 4 times negative 4, which is 16. 16 times negative 4 is negative 64. Okay, s to the squared cubed would be s to the 6th. 2 to the 6th power, well, 2 times 2 is 4, another 2 is 8, another 2 is 16, another 2 32, and another one should be 64. S to the 18th. And now we have to do 64 times 64. Okay, you might need to do some math. Didn't promise no math whatsoever. And it looks like it's going to be negative 4,096. S to the 6th times s to the 18th. Add your exponents. Means s to the 24th. Okay, final thing, order of magnitude. The order of magnitude of a quantity can be defined as the power of 10 nearest the quantity. It can be used to estimate or perform rough calculations. For example, there are about 91,000 species of insects in the United States. the power of 10 closest to 91,000 will be 100,000, which would be 10 to the 5th power. So if we were estimating, we could say that there are about 10 to the 5th power species of insects in the United States. Okay, so example 5. Okay, I hate bees, but that's what we're going to talk about right now. In 2003, the U.S. Department of Agriculture collected data on about 10 to the 3rd honeybee colonies. There are about 10 to the 4th bees in an average colony during production season. About how many bees were in the USDA study? Okay, well, they talked about studying 10 to the 3rd colonies. In each of these colonies, there's 10 to the 4th, so we would multiply those two together. Here, common base, we add our exponents, so that would equal 10 to the 7th, which would be 1 with 7 zeros following it, which is 10 million bees, which I would not want to be around. Okay, so in conclusion, our three properties, once again, were product of powers property, which means we had two powers being multiplied together. The power of a power of a product property, which is stuff being multiplied, is being raised to a power. Very mathematical right there. And finally, power of a power property is when some powers are being raised to another power. Okay, and a lot of times you're going to have to use these interchangeably. Okay, so please make sure you're good with that example 4, okay, which had them all combined together.